Accelerating pulleys. Given a simple pulley system shown at figure A, compute the acceleration of the system when released. Assume that the pulley is frictionless and that the masses are capital M and small m units. So this pulley system with two masses capital M and small m is held in this position initially, and then it's let loose, it's released. Capital M is of a larger mass and little m is of a smaller mass, and they're connected by a string, a massless rope, so that it's a constrained system. When mass capital M moves down by x, the small m moves up by the same distance x. The pulley is assumed to be frictionless. Let's get the free body diagrams of the masses, capital M and small m. So capital M has a weight acting downwards from the center of gravity and a tension T due to the massless rope, which is acting upward. So we show the forces by isolating capital M from the system. mg is acting downwards, and T, the tension of the string, is acting upwards on capital M. Likewise, little m is isolated from the system and replaced with forces acting on it. So little mg is acting downwards, and the same tension T, the tension T doesn't change in the string because the pulley is frictionless. The same tension T is all over the string. So that the capital T, the same tension as shown here for capital M, is acting upward for little mg, little mass m. So under the action of these forces, the capital M is moving downwards and the small m is moving upwards. So if we write the equation of motion for capital M, the net force on the body is the force which is causing the acceleration. So net force is force downward minus force upward, which is mg minus t. This force is causing the acceleration of capital M. Likewise, the tension is causing the acceleration of small m. Tension minus mg, the net force on small mass, is causing its acceleration, ma. And because of the requirement that the two masses are connected by a rope and the rope is passing over a frictionless pulley, the acceleration is the same for both these masses. Now, when equations 1 and 2 are solved simultaneously, we have acceleration is m minus m by m plus m times g, and the tension is 2m mg by m plus m.